Unsymmetrical fault analysis. In overhead transmission line, there is some phase symmetry between live lines having phase difference of 120 degree like this. If it is your R phase, it should be Y phase, it should be B phase, each having phase difference of 120 degree like this. Now when fault occurs in overhead transmission line, they doesn't maintain the symmetry between R, Y and B. For this case, it is the symmetry is R, Y, B. When fault occurs, the sequence will not be R, Y, B. As for example, say when fault occurs, it is your R, it is B, it is Y. Due to the fault, Y phase has gone from this position to this. So the sequence will not be RYB. So instead of RYB, if it is counted anti-clockwise, the sequence will be RBY. Now this unbalanced vector, according to fortiscue theorem, can be expressed as a set of balanced vector. The set contains positive, negative and zero sequence. For positive sequence, we have to consider anti-clockwise direction. That is, let's start with R phase R. Next B will come having phase difference of 120 degree. Next Y will come having phase difference of 120 degree. So this is called positive sequence balanced vector. Now for negative sequence balanced vector, we have to consider clockwise direction. Then considering the clockwise direction, let's draw R phase first, R. Next Y will come having phase difference of 120 degree. Next B will come phase difference of 120 degree. So this is negative sequence balanced vector because we are drawing this in anti-clockwise direction but considering clockwise direction. So now for the zero sequence balanced vector, the phase difference is zero. There is R, Y and B. So this unbalanced vector can be expressed as a set of balanced vector containing positive sequence, negative sequence and zero sequence. Now if we want to find out the fault current between three phases R, Y. Now what is operator A? Operator A means 120 degree rotation. If it is I, then when I making 120 degree rotation, it will be AI, and the next 120 degree rotation it will be A square I. So AI is equal to I angle 120 degree, that is I cos of 120 plus J sin of 120 degree. I minus 0.5 plus J 0.866 Now comparing these two terms, A can be written as minus 0.5 plus J. Now suppose this is I. When I making the rotation of 120 degree, it will turn into AI. Now next 120 degree rotation, it will be A square I. Already we found out A equal to minus 0.5 plus J 0.866. A square equal to minus 0.5 minus J 0.866. This is 120 degree rotation. Next 120 degree rotation is next 120 degree rotation. Now similarly, A cube I is equal to I angle 360. That is I cos of 360 degree plus J sine of 360 degree. It is I into 1. So comparing these two terms, A cube is equal to 1. Now properties of A. A plus A square is equal to minus 1 from these two, or A plus A square plus 1 is equal to 0. That is A square plus A plus 1 equal to 0. This is property number 1. Property number 2, A minus A square is equal to root 3J for unsymmetrical. This is also 120 degree. Now ultimately IR is equal to IR1 plus IR2 plus IR0. Suppose IR1 positive sequence, negative sequence, this is 0 sequence, IR0, IY0, IB0. Now IR is equal to IR1 plus IR2 plus IR0. IY is equal to IY1 plus IY2 plus IY0. IB is equal to, this is 2, IR2, this is IB0. Sorry. Y II1, IY2, IY0, IB is equal to IB1, IB2, IB0. Now suppose due to fault, this is symmetrical R, Y and B phase 120 degree apart. Suppose due to fault, Y phase has changed its position from this to this, like this R. Now this unbalanced vector can be expressed as positive sequence, zero sequence and negative sequence. That is, when we are considering positive sequence, that is anti-clockwise rotation, R phase will come first, then after 120 degree, if it is balanced, B phase will come, next B, after that Y phase. This is each having phase difference of 120 degree. It is balanced positive sequence. And when we are considering negative sequence, that is clockwise direction, first of all R, then Y will come, and B will come, having phase difference of 120 degree. This is negative sequence, and R, Y, B. This is zero sequence having phase difference of 0 degree. So this unbalanced vector can be expressed as positive sequence, negative sequence and zero sequence. Suppose this is IR, this is IB and this is IY. So IB can be written, this is IR1, IB1, IY1, IR2, IY2, IB2, IR0, IY0, IB0. So IB1 can be written as AIR1 and IY1 is equal to A square IR1. So for the negative sequence, IR2 is equal to IY2 is equal to AIR2, IB2 is equal to A square IR2. Now IR is equal to IR1 plus IR2 2 plus IR0, that is equal to IY equal to IY1, IY2, IY0, that is equal to IY1 is A square IR1 plus IR2 is equal to A IR2 plus IY0. Now that is equal to A square IR1 plus A IR2 plus IR0, because IR0 is equal to IY0 equal to IB0. Now it is vector, this is equation 1, this is equation 2. Now B vector, that is IB1 plus IB2 plus IB0. IB1 is equal to A IR1 plus IB2 is equal to A square IR2 plus IR0. A square A IR1 plus A square IR2 plus IR0. This is equation 3. Now 1 plus 2 plus 3 is equal to IR plus IY plus IB equal to your 1 plus A square IR1 plus 1 plus A square IR2 plus 3 IR0. It is equal to 3 IR0. Now IR0 equal to 1/3 of IR IY IB. So IR0 is equal to 1/3 of IR plus IY plus IB. Now the zero sequence current, that is IR0, can be written is equal to I0 equal to 1/3 of IR plus IY plus IB. Similarly, positive sequence current, for positive sequence current, IR plus AIY plus A square IB is equal to IR1 plus IR2 plus IR0 plus A into IY1 plus IY2 plus IY0 plus A square IB1 plus IB2 plus IB0, that is equal to 3IR1, because A plus A square plus 1 equal to 0. Now IR1 equal to 1/3 of IR plus AIY plus A square IB. Now negative sequence current. So IR plus A square IY plus AIB, that is IR equal to IR1 plus IR2 plus IR0 plus A square, IY is equal to IY1 plus IY2 plus IY0 plus A, IB1 plus IB2 plus IB0, it is equal to 3IR2. Or IR2 is equal to 1/3 of IR plus A square IY plus AIB.